All right, just a short video on sedimentary rocks, since that's one of the lab assignments that you're covering this week. There's three types of sedimentary rocks. So we have clastic, which is also referred to as detrital. We have biochemical, which can also be referred to as biogenic or bioclastic. And then we have chemical. So for those three subtypes of sedimentary rocks, we're looking at, again, the texture and the composition. So if you think back to minerals, we were looking at the physical properties of the minerals in order for us to identify what the mineral was. When it comes to rocks, you guys are looking at the texture and the composition, so those two properties. When it comes to clastic or detrital sedimentary rocks, because it is composed, or those rocks are composed of weathered pieces of other rocks, they're fragments, they're bits and pieces, detritus. You're not really looking at the composition, you're looking more at the texture. Obviously the composition is just going to be rock fragments. So for the texture, we look at the grains that make up that clastic rock. So what are the size of the grains? Are they gravel size, sand size, silt size, mud clay size? We look at the shape of the grains. Are they rounded? Are they sub-rounded? Are they angular? Are they subangular? Mostly are they just rounded or angular? And then we look at the sorting. Is the rock, or the grains within the rock, is it well sorted or poorly sorted? So well sorted sedimentary rock means that all of the grain sizes are roughly the same size and they're all roughly the same shape. So something like a sandstone or a siltstone is very well sorted because all of the grains are roughly the same size. They're either sand size or silt size. So that is clastic sedimentary rocks. We also have biochemical, which what I tell my students is just think if it has shells in it or is made of plant material or decomposing plant material like coal is, that is a biochemical sedimentary rock. Chemical sedimentary rock. So the opposite of clastic, where we were just looking at texture, chemical sedimentary rocks all have a crystalline texture. It's either microcrystalline, where you can't see the individual crystals, it just looks nice and smooth, or it can be blocky crystals, like in a rock salt, which is got huge crystals of halite. So what you look at, or what you try and identify in a chemical sedimentary rock, is the composition. So what is it made of? So some examples could be calcite, quartz, or the salts gypsum and halite. So remember back to the physical properties that you would use to identify the minerals. You're going to do the same kind of thing when it comes to the chemical sedimentary rocks. So for calcite, a few of you I was having you drop vinegar on your mineral samples, and that's because vinegar is acetic acid. And so it's a dilute acid, and calcite is one of those minerals that fizzes with acid. Quartz, if it's quartz, it'll scratch glass. Your rock sample will scratch glass. So like a chert that is made of microcrystalline quartz should scratch glass. And then gypsum, which was one of your minerals that you identified last week, and you could scratch that with your fingernail. Halite is rock salt, and so it should taste salty. So you might be asked to lick a rock or drop some acid on it, and that's okay. That is part of the process. One thing that I also wanted to throw in here is making sure that you guys remember the steps to making a sedimentary rock, because this ties into the texture of sedimentary rocks. So remember, first we have to take some kind of parent rock and weather it, so either mechanically or chemically break it down. Then we erode it, and during erosion you remove those weathered pieces away from the rock substrate. Then you transport by either water, wind, or ice, and you deposit it somewhere, and then those grains, those individual components, go in under compaction, and cementation, where you fuse them together, and that's the lithification process, and that's the last step to making a sedimentary rock.